Good morning and welcome to the 2021 PrecisionU.
Our speakers today are Aaron Wilson and Bob Nielsen. Aaron's up first. Aaron Wilson is an atmospheric science research scientist at The Ohio State University, holding a joint appointment with the Bird Polar and Climate Research Center and OSU Extension. He is also with the State Climate Office of Ohio. And all of this is to say, Aaron loves weather and climate. And who doesn't? He loves to engage the community on topics where weather and climate intersect our personal lives. What better topic is there than agriculture? Aaron says farmers are his favorite community because no one else tells him their local temperature to a 10th of degree and precipitation to the 100th of an inch like farmers. Indeed, we are all meteorologists. So thank you, Aaron, for joining us today. We look forward to hearing from you.
Absolutely. And then our second speaker is going to be Dr. Bob Nielsen. Bob joined the agronomy faculty at Purdue in 1982 with statewide responsibilities for applied field research and extension programming with an emphasis on corn management practices. He conducts field scale research currently focused on identifying the optimal management of nitrogen fertilizer, seeding rates, starter fertilizer, sulfur fertilizer, biological in-furrow amendments, and the use of small UAVs for crop scouting and field research. So you can ask Bob really any question, it sounds like. So his extension programming focuses on optimizing yield, profitability, and stewardship of corn production for growers in Indiana, but also throughout the Eastern Corn Belt. So welcome to Bob and Aaron, and we're going to go ahead and let Aaron kick it off.
Yeah, so we're going to be talking about short and long-term weather impacts on spring planting. And before I get started, certainly this winter background I had behind me here, certainly a good time of the year to start thinking about this. Really, this talk is threefold. One, to first think about 2020, put it into context, what we experienced, and talk about the terms of weather and climate, what I mean. Look at some longer term trends that I think are really impacting springtime planting decisions and the impacts that we're seeing out there. And then I'm going to leave you with 2021 outlook. What are we expecting over the next 3 to 4 months as we look forward to planting season here coming up? So, just to kind of start and wrap our heads around, we experienced weather similar to what this photo is showing you here, which is, we're in the middle of Auglaize County here in the summertime. We can tell that it's warm, corn's up, cumulus clouds popping up because humidity's up. As meteorologists, we take that information and then we translate that into weather maps. We collect a ton of data, and then we put this on weather maps and we forecast the movement of fronts and things like that across the surface of the earth. Now, over a long period of time, we collect a lot of data, just like farmers, right? You collect a lot of data in your fields these days. That data can then be compressed and interpreted, and we can get certain bits of information that then we have to take back into the community to think about things like drought and drought monitoring and how that's impacting our crops, or extreme precipitation events and how that might be leading to difficulties that we see in the field. So this is the whole weather process that I think is very, very important. Now, if you've seen previous talks, I always start here. When we think about the weather, we're talking about high frequency changes, really fast-paced changes in temperature, wind speed, moisture across the surface of the earth. We necessarily, look out our window and we can't see these patterns, but as meteorologists, we step back, we look at the big picture here, and we can see certain weather patterns set up across the globe. Our weather generally flows from west to east here in the Northern Hemisphere over the United States, and over a long period of time, those weather patterns establish what we expect for any given day, season, or the like throughout that entire year. Now, those longer term changes, the changes in those longer term weather patterns are what we call climate. So if we zoom in into the picture here, it's hard to see what's happening. If you haven't seen this before, and I would be shocked if you haven't, because I use this every time. We zoom out, we can use a walking dog example for weather and climate here. So, we're walking our dog on the leash. It's driven by some natural desires, right? Fire hydrants and food wrappers and good looking dogs on the other side of the road. That dog is moving back and forth in that chaotic motion. Now, we still expect them both to be where that finger's pointing in a minute or two. And what do we base that on? We base that on the path of the dog walker. So even though that dog is meandering back and forth in a seemingly chaotic fashion, they are moving generally in the same way. We can describe the mean path, the average long-term path of that dog by the dog walker. So this is the way we can think about weather and climate. The dog being our weather, the climate being the dog walker. And even though at any given time we can have a record heat in the winter or record cold in the summer, over time they do correspond to one another. So it's just, I think, a great illustration to put those two together. So you took a little poll here we're at the beginning, and we were looking at, the question was whether the 2020 weather was what for your operation. Nobody said perfect, which is fantastic there, but you could see you still had some average to less than ideal conditions, right? And a few, I'm so tired of this. I wanted to throw that in there just to let you vent a little bit. So that is great, and I appreciate you taking that poll. So let's look at 2020 Midwest growing season here. Now, I'm going to define it here as March through November. So those months from March through November. And if we look at the whole season, what you're looking at are anomalies or differences compared to our 30-year mean. That's what the National Weather Service establishes as our normal values between 1981 and 2010. All the gray shading you see on these maps, that's close to average. It's really within a degree or of average either way, above or below. But you can see in our daily highs across much of Ohio, Michigan, Indiana even, we had daily highs that were a little bit above average, and certainly our overnight lows. You see a lot more orange in the right-hand side, which are overnight lows during that period, and that's a really common theme, and we're going to discuss that a little bit further in detail. But as far as this March through November period, this was Ohio's 11th warmest March through November, and Indiana's 31st warmest. So to put it in the context, that's what we saw over this growing season. Now, we could break that down even further, right? We could think back to our springtime last year. Now, on average, you see a lot of grays across our region here in Ohio and Eastern Corn Belt region, right? Average to slightly above average. March was very warm. April and May, not so much, right? We were dealing with these late freezes, and we'll see that in a moment. And again, if I take a warm month and a cold month, I divide by 2, climatologically speaking, it's an average season. So averages hide those details that are very important for agriculture. And it's important, we're going to tease those out as I move along in my talk. We had our 6th warmest July on record here in Ohio. Very warm summer, Ohio, much of the Midwest, above average to near record warmth. And then above average conditions continuing into the fall as well, especially in September, less so in October. But then we got into November, and for instance, Dayton, Ohio hit 80 degrees for the first time on record, going back to 1895. And I should note that these are averages, or the rankings go back to 1895. So first 80-degree temperature in the month of November for Dayton, Ohio, there in the early part of November. What about our precip? Again, looking at the full March through November period, we had anywhere from 30 to 40 inches across much of Ohio, southern Indiana, and Illinois. Less so, stretching from central Illinois northeastward across northern Indiana and northwest Ohio, where certainly drought conditions built across that part of the region, and we're still dealing with abnormally dry to moderate drought conditions there. Overall, this was the 35th wettest and 63rd wettest for Ohio and Indiana, respectively, for this season. Again, that's for the entirety of that March through November period. But I want to break it down a little further, right? We could break this down into the different seasons, and we define spring as March through May and summer as June through August. And you can see some differences. Now, we had a little dry drought conditions setting up in Indiana earlier in the spring, but elsewhere, we had a wet spring, very wet conditions, especially here in central Ohio and points eastward, which dramatically switched by the time that we got to our summertime, with those very hot conditions and a lot less rainfall falling over those summer months. So you can see the deficits here running anywhere from 3 to 9 inches for our summer months here from northern Illinois across northern Ohio. So very different seasons in terms of spring and summer. And of course, that plays into decisions that you all make in terms of planting and dates and how to manage that throughout the growing season. Let's drill down further now. Let's pick a particular city. This is Greenville, in Darke County there in west central Ohio. And we're just going to look at Greenville to pull out some more key tidbits here. So this is Greenville, the daily highs and lows, right? Record highs would be the dark red and record lows would be the dark blue. And average is the green the green shading there. So this is how we experience weather, the day-to-day variability. So we had record warmth last winter. It was the 5th warmest winter on record going back to 1895 for Ohio. We had a rather warm March, followed by a very cold April and May, multiple freezes, some slight corn damage, obviously, to early planting, and combined with some moisture, there was some replanting, obviously, taking place across the state. And then this extreme warmth that we had in late fall and even early winter here. So you could see some of the, the key different, I would say more discrete events that we've seen along the way. Looking at much of the growing season here, pretty temperate for this location. Again, July was pretty warm, especially in overnight lows. But when we got into August and September, things relaxed just a bit, which given the dry conditions, probably helped keep things from getting a little bit worse out there across our region. Now, what about the rainfall? This is the precip for the entire year, January through December. And at Greenville, they saw 3 events between 1 inch and 1.5 inches, and 2 events over 1.5 inches. So in 5 days this year, this site received 20% of its annual precip. This is actually pretty, I would say, benign compared to what we've seen in 2019, 2018, when we saw a lot of locations seeing 8 to 9 events that basically made up 40 to 50% of their annual rainfall. So this is another key element to this that I'm going to unpack in just a second. But so we saw 30% of our spring rain, our annual rainfall in spring, and 21% in summer this year. So again, that summer deficit compared to what we typically see. All right, so those are the conditions that we've seen there. So what if we pull back a little bit and kind of revisit that first map data figure that I showed you? Certainly temperatures have been getting warmer throughout the 20th century. 2019 ranks as the second warmest since 1880 for the globe. 2020 will probably take that spot after we've finalized the numbers this month. 9 out of the top 10 warmest years for the globe, all since 2005, 5 warmest years since 2015. And if you were born after February of 1985, you've never experienced a cooler than average month for the planet. So we know our temperatures are getting warmer, but there's some key processes that are taking place that really impact the Midwest and where we live here. We deal with these things called greenhouse gases, water vapor and carbon dioxide. They keep our atmosphere warmer than it otherwise would be because they absorb all the energy coming off the surface of the earth. And as we increase, we get warmer, we get more water vapor in the atmosphere because of the water cycle. Okay, so this water cycle of evaporating moisture, condensing it into clouds, precipitation falling, and then runoff from the surface is actually intensifying. So as we increase our temperatures, our evaporation, evapotranspiration increases, we get more moisture in the atmosphere. It leads to more precipitation. That could also lead to more runoff, heavier events, erosion, nutrient loss. All of these things play into this intensified water cycle. But if you're evaporating more from the surface as well, given warmer during the warm season, then you can increase moisture loss from the surface as well. So it's not just an excess water, but we're also thinking about deficits during critical periods of the year as well, right? So we've got all of these impacts that are taking place across the US, and they're different for different regions. Out west, it's heat waves and wildfires. The southeast, we're concerned about the intensifying extreme hurricanes, category 4s and 5s. But here in the Midwest, we're dealing with the extreme precipitation events. These heavy events that lead to these erosion loss or inability to keep nutrients on the field, things like that, right? So here we have $1 billion disasters, and another poll is going to go out, and we'll address that here in just a little bit. Kind of the last little piece of what it is like for Ohio and Indiana. We've seen US billion in 2020, we saw $16 billion weather and climate related disasters, and they've all been put on the same scale since 1980. Typically, we've seen 12 to 16 frequently over the last decade. And if you look at Ohio, Indiana, and much of the Midwest, it is through the face of water. It's through these rain-related disasters, flooding and flash flooding, that do a tremendous amount of damage, and I would argue is a big challenge and a big obstacle here for agriculture throughout the Midwest. Okay. All right. So some trend maps. How are our seasons changing, and how does it play into our spring decisions here? If you've seen talks in the past, I've done a lot of analysis with mid 20th century. These are actually from the last 30 years, just trends since the 1990 to 2019 for winter, spring, summer, and fall on the left. So you can see we've not had a lot of change in our winter. These are degrees Fahrenheit change per decade. So you can multiply them by 3 to get the 30-year period. Generally, it's been within a half a degree per decade warmer or cooler during winter, but we have been slightly warmer here across much of Ohio. When we get into spring, we have seen increases in our spring temperatures, especially across much of Ohio, southern Indiana, and southern Illinois, on the order of a degree and a half to 3 degrees over that 30-year period. If you look at the summertime, it really shifts toward the Great Lakes. We've actually seen a de-intensification of, say, our 100-degree days. We see more frequent 90-degree days, but because of that increased water vapor, we don't see those extreme temperatures as often as we did in the 20th century. And then overall, fall warmth is the trends are really strong there. So we've seen overnight lows during the fall drift as high as 4.5 to 5 degrees warmer just over these 30-day period here across the Midwest and the Great Lakes. So it's really important to think about these more recent trends in our climate. And then, of course, the gorilla in the room, that the seasonal precipitation changes. We've seen pretty strong increases in our winter precip across Ohio and Indiana, a good inch or so per decade, so a good 3-inch additional rainfall essentially is what we're seeing during our winters. Spring as well, especially as we get into west central and northern Ohio, much of Indiana. Summer as well, more so in southern and northeast Ohio, for instance, in southern Indiana. But there is an area there, west central and northern Indiana, that we look at, and we could tease out just a single month, July, and I'm showing you that on the right. This is the July precipitation trend, and you can see deficits. You can see a decrease in the amount of precip across northern Indiana, west central Ohio, in the order of an inch per year, or an inch per decade. So again, we get more rainfall in the cool season, fall, winter, spring, but there are some months and some trends that we're seeing where we get a downturn in the precip over the last 30 years. And again, that provides another challenging context in terms of managing, when we plant and then what impacts that has during the growing season. I'm sure Bob's going to, talk a lot about that as well. So if we look at Ohio's top 10 winter through spring, January through May, 8 of the top 10 warmest and 5 of the top 10 wettest have occurred since 1990. So the point of this is that it's not just what's happening in spring, but it's also what's happening in winter and even fall that lead to conditions that are challenging for our spring planting decisions. But there's no doubt that we're warmer and we're wetter than much of the last 130 years in Ohio's history here. So we see that in terms of our rankings overall. And of course, we're dealing with the extreme precipitation events as well, really over the last 20 to 30 years, where we see a large number a higher number of extreme precipitation events versus the early part of our record here, where, we had some flooding years, 13, 37, 59, are really within those other peaks. So we're under a persistent flood risk and a flood threat, which makes certainly planting decisions challenging. So there are a lot of impacts. We've only got a few minutes today. I want to hone in on one thing that I've been watching and monitoring, is looking at the suitable fieldwork conditions as reported by NASS. And this is for Ohio. And I'm going to pick 4 months here: April, May, June, so the spring months, and October. So if you look since 1995, both months of April and October, we've seen a decrease in 5 suitable fieldwork days on average, right? The linear change year over year since about 1995. So a decrease in those early planting field days, and then also in our harvest days in October. May, what about May? A slight decrease, but certainly I would say nothing that really stands out. So pretty flat in terms of our May conditions here in Ohio in terms of suitable fieldwork conditions. And then I would argue, if you look at June, right, if we pull out June, we've actually seen an increase in suitable fieldwork conditions and days in June. Now, I'm not being prescriptive here about planning and planning dates, but certainly this opens up the opportunity to have more discussion or broader discussions on windows, windows of opportunity. And of course, this is just one thing to consider with the planning decisions. But I think it's really interesting if you look at these different um, these different trends here. Sorry, I was thrown off by the poll, but there we go. So we'll come back to the poll in just a second. If we're looking at future climate, we're moving into the mid 21st century here. We are looking at temperatures 3 to 5 degrees warmer by about 2050, especially in our overnight lows and during the wintertime. Then we're also looking at precipitation increases that are much of what we've seen, which are seasonal changes in atmospheric circulation, jet streams changing so that we get more rainfall in fall, winter, and spring. And then perhaps, and it looks like, decreasing trends to continue in summer. So we're intensifying that evaporation, intensifying that hydrologic cycle, more off-season rainfall, making harvest and planting more difficult, and then a lack of rainfall during growing season certainly presents a lot of challenges. So I've shown you this in the past. What's our, is this our new normal? We're certainly trending in this direction, where we see an Ohio climate trending toward the mid 21st or the mid-Atlantic and Arkansas by the time we get to the end of the 21st century. So what does that mean for agriculture, right? What does that mean when we've got these intense precipitation events during spring that challenge all of that as well? So I'm not sure if I can pull that back up, but there we go. Thank you, Elizabeth. Yeah, so I had asked, the most detrimental weather to your spring planting in recent years is the excessive rainfall. And I sort of thought that was going to be the case, but it was good to verify it here. And certainly that is the challenge now and as we move forward. All right, so in the last minute or two, I want to wrap up with looking at what we're seeing this spring. So we're in a La Nina pattern. That just means that the tropical sea surface temperatures over here out between South America and Indonesia are cooler than average. And that has impacts on our atmospheric circulation. And here across North America means we get this highly amplified variable jet stream, a lot of highly variable weather. Cold air outbreaks are usually short and very wet conditions, right? Very, very wet conditions across Ohio Valley, generally speaking, right? And if we look at our what's happened in previous La Nina events, along with our overall trends, it tends to be warmer during winter. It tends to be a lot wetter, and you can see that in this composite here in the upper right-hand side. And oftentimes it's snowier for Indiana and Ohio as well, depending on how much cold air we get from the Arctic, okay? So if we look at our seasonal outlook right now, this is the next 8 to 14 days. Temperatures across much of Ohio and Indiana look to be about average for the next 8 to 14 days. And beyond this, there are some hints that we've got this polar outbreak, polar air that could be shifting into the eastern U.S., and it could provide also a very snowy pattern giving our La Nina. Now, what we've not seen really is a big increase in rainfall. Certainly last week's event where we had 1 to 2, even 3 inches of rainfall across parts of southern Indiana and Ohio were felt, but we're really looking at dry conditions now over the next couple weeks. And then as we look at February, March, and April, it certainly looks warmer than average. And this La Nina pattern here in the bottom right, it's typically very it's on the wet side of things here across the Ohio Valley. So kind of to wrap up all of this, obviously, I think we're expecting a soggy start to the 2021 planting season, provided that our La Nina pattern really kicks in here as we head through the rest of the year. And of course, if you want to show those last poll questions here, feel well prepared. A lot of you feel prepared to withstand the changing conditions, but a good 41% of you that don't. And hopefully you'll follow some future talks, and we'll talk more about resilience side of things as well. So spring planting, I think, hinges obviously, as you know, a lot more than just spring precip, but strong trends in that January through May, both in the temperature and the precipitation field. So with that, I'll turn it back over to Elizabeth and Mary. Thank you.
Thank you, Aaron. And we'll hand off now to Bob.
All right. Thank you, Mary. For those of you that don't know me, I'm the extension corn specialist at Purdue, across the border, as it were, in Indiana. And somehow I got roped into this discussion, but I'm glad to do that. I've done a lot of programs in Ohio over the many years that I've been at Purdue. So let me get my presentation up and running, and let me share that. And hopefully everybody now is seeing this presentation. So Aaron certainly gave us a lot to think about. Some of it is probably not surprising. We've been living through these changes in weather for quite some time, but I got to say, as an agronomist, as we think about the possibilities for the next 20 years or 30 years, in terms of what the weather is going to do and the changes in climate, I got to admit it gets a little scary. And frankly, I think one of the biggest challenges we have as corn and soybean growers is to figure out how can we manage these unpredictable extremes in weather. So I just want to share with you a few slides on the impact of this kind of variable and unpredictable weather on the decisions that we make in the spring. Let me get this going. So certainly, as Aaron pointed out, one of the key concerns in recent springs, and apparently for the ones to come in the future, is this uncertainty about wet and cold. And that seems to be one of the most common kinds of events that we get anymore in the spring. And because it's unpredictable, it's, again, from an agronomic perspective, it's just a little hard to manage. But certainly when we get these wet, cold conditions in March and April and into May, certainly it disrupts the timeliness of spring field operations. And it's a wide range of operations. It disrupts spring tillage. It disrupts our nitrogen fertilizer plans in the spring. It interferes with our herbicide applications, and obviously it interferes with planting. So, this is one of the, probably the key concerns about this wet, cold conditions in the spring, is that it just disrupts everything. And then from the plant's perspective, and I'll focus on corn since that's my area, certainly it increases the probability of poor germination or uneven germination. The same is true for emergence. And then for the rest of the stand establishment period, also it's increases the risks of just getting poor, uneven stand establishment. And because of that, it obviously increases the risk of replanting. And so it just adds this level of uncertainty to our spring operations that certainly frustrates the devil out of us, and just makes it challenging to get these crops off to a good start. So let me just emphasize some of the risks of this wet, cold conditions that occur prior to planting. And I've already indicated that it gives us fewer opportunities for spring tillage, gives us fewer opportunities for nitrogen applications prior to planting, herbicide applications, whether they're burned down or burned down and residual. And because of that, I keep losing my mouse as these polls come up for some reason. And so because of that, one of the consequences is that we have a much higher risk of getting unsatisfactory control of these weeds in the burn down operation, and or the residuals don't do their job, and so we don't do a good job getting control of weeds as they're germinating near planting or after planting. And so weed control has become a little harder to work with. And again, forgive me, but I keep having to force this back to my mouse. I think it's because of these polls that keep popping up. I'm trying to figure out if I can make it better. The other risk that comes along with these wet, cold conditions in the spring is obviously, this gets back to the fewer number of working days that Aaron talked about, is we just have fewer opportunities to be in the field when soil moisture conditions are fit. And too often we're doing tillage when it's not fit, and we're creating soil compaction with the tillage tool itself, with the tires of the equipment, when we're putting on nitrogen, when we're putting on herbicide, when we're running through the field with heavy equipment, we're creating compaction. Planting operations, it seems like it's fewer and fewer opportunities to also be planting when soil moisture conditions are right. And so we're creating a range of different kinds of soil compaction with the planting operation. And so this risk is simply higher with this higher likelihood of wet and cold conditions. And then maybe the final risk that occurs prior to planting, especially if you're conventional tillage, is that it simply increases the risk of ending up with a really poor seed bed. And it might be seed beds that have a lot of surface clods, seed beds that crust easily after planting with heavy rains, and just very poor conditions for getting good germination and emergence. So as we think about the impacts of this variable and extreme weather on stand establishment, I want to emphasize that when I talk about stand establishment, it doesn't stop at emergence of the crop. It's a period of time that goes from planting and about the next 45 days after planting. And basically, stand establishment ends at about the time the crop reaches the 6th leaf collar stage. So generally speaking, throughout Indiana and Ohio, that's roughly a 45-day period after planting. So a pretty lengthy period for the stand establishment to occur. And certainly at the end of that period, we don't want fields that look like this with areas of the field that are nice and green and growing well, and areas of the field that were either delayed in emergence, or they're struggling because of wet feet, or they're struggling because of seedling blight. This is not what we want to see 45 days after planting. And understand that this stand establishment period from planting to roughly V6, the plant population that you have at V6 is pretty much what's going to be there at the end of the year. So when we talk about yield components of plant population, ears per plant, number of kernels per ear, and the weight per kernel, that first yield component of population is pretty well set during that first 45 days. And if conditions are not good and not favorable during those first 45 days after planting, we end up with final populations that perhaps are thinner than we want, but maybe just as importantly, populations that are uneven and poor. And when we get to V6 with a ratty looking stand that's uneven and not uniformly healthy and struggling, that struggle is going to continue for the rest of the season. So when we get out to middle of the summer or late summer, when Aaron tells us that Julys tend to be now drier than normal, this ratty stand at V6 is simply not able to tolerate those dry conditions that occur later in the summer, compared as if it were a uniform stand. So again, this stand establishment period determines population first of all, and the uniformity of that stand, which sort of defines its ability to tolerate stress later on. And obviously, all of this influences yield potential. And so when we're looking for ways to increase yields, when we're looking for the secrets of achieving high yields, we need to remember that this stand establishment period is pretty important and pretty critical to determining that final yield potential. So some of the risks at planting when we get conditions that are not fit, obviously a lot of it has to do with the operation of the planter. And so this slide is illustrating obviously a poor emerging plant. It's sort of curly cueing all sorts of directions below the surface and never reached the surface. And sometimes we blame this on cold weather, but in this particular example, this is simply due to extreme sidewall compaction of the planter furrow, coupled with a really forcible closure of that furrow to get it closed, and those sidewalls being so compacted and pressed together so hard, it literally limit the ability of that coleoptile and the mesocotyl to emerge to the surface. So this is one of the risks that comes along when we have both conditions that are a bit wetter than we want, but also cooler than we want during planting. And so along with this, cold, wet conditions at planting obviously increase the risks for surface compaction if we're really having to increase the down pressure on those closing wheels to close those furrows. If you are no-tilling and you have a lot of surface residue, and if the surface conditions are damp, that surface residue gets stringy, it gets difficult to slice through with the coulters. It becomes more likely that we're going to pin that residue down in the furrow, and so we don't get good seed to soil contact. Instead, we get seed to residue contact, and so it can create a lot of issues if we're not able to move that residue out of the way nicely with the planter. And then, of course, especially in no-till, but even in conventional, sometimes the soil moisture is such that we just cannot close those planter slots effectively, and leaving it open to the air, and obviously that's not good for germination. So these are some of the risks that we incur when we have these cold, wet conditions at the time of planting. And then once it's planted, the risks don't die, they don't disappear. And so some of the risks that can occur during stand establishment include slow germination and emergence. This is a field several years ago up in north central Indiana. It was planted fairly timely. It was planted, I think, the first week of May. But it was followed by 2 or 3 weeks of just nasty, cold, damp, wet conditions. It's a strip till field, but the rows nevertheless still crusted over. The plants were germinating slowly because the soils just never warmed up. They were hovering around 50 degrees, and they weren't germinating very fast. And then there's this surface crust that limited some of the emergence of the crop. And so we had a lot of leafing out underground. And then 2 or 3 weeks later, the final nail in the coffin was the development of seedling blight as the seed treatment began to wear off. Well, one of the points I want to show or make with this photo is that clearly you see some differences in that field relative to planter passes. And what you're looking at are 2 different hybrids in that field. So as we look for ways to manage this unpredictable extreme weather that we seem to be getting more and more, one of the tools we have at our disposal is to choose hybrids that are tolerant to a wide range of stresses. Early season, we're talking about good seedling vigor, genetically good seedling vigor. We're talking about the ability to tolerate cold soils better. We're talking about the ability to tolerate wet feet a little bit better. And we're looking for hybrids that tolerate stress better, because clearly in this particular example, one hybrid clearly fared through all those problems better than the other. And I dare say if the farmer had known ahead of time that there was such a difference in the early season stress tolerance among these 2 hybrids, he might have made a decision not to use the one hybrid. So keep that in mind. In addition to slow germination, you've heard us talk about this thing called imbibitional chilling. And this is one of these stresses that occurs when you plant corn, maybe a day or 2 ahead of a really sharp drop in temperatures, and where the soil temperatures also drop sharply. And the damage occurs when seeds absorb or imbibe cold soil moisture. And of course, it has to do that to kick off the germination. But when the moisture that it's imbibing is cold and it chills that tissue down, as that seed takes in the water and begins to swell, sometimes the plant tissues, being cold, they just are not as elastic and they tend to rip. And that ripping of the cell tissues in the seed can cause death of the seed, or it can certainly stunt the germination process. So this is what we mean by imbibitional chilling, and it's this almost weird kind of phenomenon that is one of these things that has to be timed just right or just wrong, as it were, with the onset of the sharp drop in soil temperatures. But nevertheless, it's one of the risks during stand establishment. We already talked about the fact, and we all know that a dense surface crust can certainly hinder emergence, and this is a consequence of heavy rains after planting. And then I've already shown you the one example of emergence that is hindered by sidewall compaction and furrows being forcibly closed. Some more risks that occur during stand establishment that we see from time to time. This is an example of what we call corkscrewing and eventually leafing out underground. And it's the consequence of the mesocotyl. And of course, the mesocotyl is what connects the coleoptile or the spike with the seed. It's that white piece of tissue that's the part that elongates during emergence. And when that mesocotyl experiences injury from cold soils, the part that becomes injured becomes less elastic, and so it can't elongate like the rest of the mesocotyl, and so it begins to do this curlicue or corkscrewing kind of fashion below ground. And again, it's a consequence of cold soils and the injury that can be caused by that. If we get these excessive goose drowners that saturate soils for days after planting, the crop can literally just die by drowning. And then I mentioned earlier that as this fungicidal seed treatment deteriorates, and understand that most of the fungicidal seed treatments that are used today have a lifespan of maybe 2 to 3 weeks once the seed is planted, and then it just naturally begins to deteriorate. Well, at 2 or 3 weeks then, if the plants are still not at stand establishment and maybe they're still struggling, then you get all the seedling blights begin to move in. And we see this time and time again where we get the crop planted and it just sort of sits there for 2 or 3 weeks. It doesn't do anything. It's too cold. Nothing's happening. The seed treatment is slowly wearing off. And then finally we get some warm conditions where the crop finally begins to come up and we sort of breathe a sigh of relief, and then bam, all of a sudden seedling blight comes in and takes it out. So it's another risk that occurs when stand establishment conditions are cold in particular, but also cold and wet. And ultimately, the final risks of what happens during stand establishment times that are rough and challenging is that ultimately the stands may thin out enough that it forces you to replant. And certainly in the last couple of springs, depending on where you are in both states, there's been a lot of replanting that's going on, more than we normally see. And so even if the crop emerges well, even if you get a good stand of corn at emergence, but in the next 45 days, if conditions aren't good and the plants become slow and uneven in their development, and you end up with fields that maybe look like this, where, again, part of the field in the background looks pretty good, but the part in the foreground, you really wouldn't wish that on anybody. This kind of problem again, is what occurs in that first 45 days. It sort of sets the stage for the rest of the season. If the seed furrows have been compacted, if there's sidewall compaction in the furrows, then sometimes that can be severe enough that it limits the growth of the nodal roots or the permanent roots to the furrow for some time. And certainly that's not good for the plant. And then in general, if soils are wet during those first 45 days, if they're cold, if there's maybe some shallow compaction due to spring tillage that was done on wet soils, all of that can lead to shallow rooting and forcing those plants to survive with roots perhaps only in the upper 6 inches. Well, then when we get to mid-season and we get the drought set in like happened this past summer, suddenly those shallow rooted plants are so much more vulnerable to the effects of that dry weather, and just increases the odds of that drought stress having severe consequences. So I'll finish with this slide and just list maybe a few factors that I think are important for success in stand establishment. And maybe this will lead to some questions as we move on for the rest of this. I think one of the key factors, as we appear to be moving towards seasons that are more unpredictable, more extreme, I think probably one of the most important factors is patience. And I know that's easy for me to say. But I think too often in the heat of the planting moment, we're just so intent on getting this crop in the ground that we lose patience and we do things that we regret later. So I think we're going to need more and more patience over the years to come as we move towards what appears to be a more unpredictable and unreliable kind of weather conditions. While I often make fun of people like Aaron as weather forecasters, nevertheless, the short-term weather forecast, the 6 to 10 day forecast, even the 8 to 14, in my opinion, are reasonably good. And I think too often people don't pay attention to those short-term weather forecasts when they're making some of their decisions. And the classic example of this is when there's a cold front that's been forecast to come in the next 3 or 4 days, and it looks like it's going to be a really sharp cold front, and the odds are those soil temperatures are going to drop like a rock. It does make sense to begin slowing down your planting operation, and in particular avoid planting the day before that cold front hits, because that will reduce the risk of imbibitional chilling. And I've been in situations where afterwards, when we go out and diagnose imbibitional chilling, and then we ask the guy, well, weren't you worried about that with the weather forecast? And it turns out they hadn't even been paying attention to them. So again, pay attention to weather forecasts, particularly the short-term weather forecasts, as you make some of these planting time decisions. Clearly, if we're really dealing with fewer number of working days, which influences tillage and nitrogen applications and herbicide applications, but also planting, clearly we want to make sure that the planter itself is ready to go. And again, this probably goes without saying, but let's make sure that planters are tuned up well ahead of time. Any repairs are made, that all of the necessary adjustments are ready to go, and just be ready to plant so that you don't experience downtime in the fewer number of working days that we have. I would say that for those who are conventional tillage, there are opportunities to avoid some tillage trips that really aren't necessary. And I see this over and over and over again, where some people just seem bound and determined to beat their fields to a pulp and beat them into submission before planting. And then we get the heavy rains after planting, and we get the surface crusting. We have the compaction due to the unnecessary tillage. So again, if you're conventional tilling, I would still encourage you to look for ways to reduce the number of tillage trips that you make. And if your soils are suitable and adaptable for moving towards reduced tillage or strip tillage or pure no-till, certainly begin to look towards that. And because all of this, what it's doing is it's minimizing the risks of creating soil compaction. And I think this is one of the biggest concerns or biggest risks we face as we get into these extreme weather events with soils that never quite dry out, and they're really never fit to work. And so we create the soil compaction. And of course, soil compaction is one of these gifts that keeps on giving in terms of the effects that it has on rooting. So look for ways to minimize soil compaction. Operate the planter smartly while planting. Make sure if it's a bit on the dry side, make sure you're planting to moisture. If it's a bit on the wet side, don't plant too deep. Try to avoid smearing the sidewalls. Try to wait that extra day to start planting. And part of that leads to this next factor is try not to obsess over planting date. And by that, I mean, don't worry unnecessarily about late planting. And Aaron sort of alluded to this in some of his final comments, but honestly, we've had some late planting seasons in the last 5 years or so, and almost invariably, what we realize from those late planting years is that late planting in and of itself is not a kiss of death on yield. This past year, some of our own field scale trials were delayed because of some wet soil conditions in the spring. And again, we ended up with yields well over 200 bushel in these late planted fields that were late May, early June. And sometimes we laugh at ourselves and say, well, why do we plant in June all the time? Because we seem to be able to get good yield. So, I'm not saying we should intentionally plant that late every year, but I'm also saying let's not get too consumed with the prospects of late planting. And if that gives us a chance to wait and maybe get those soils in a little more fit conditions before we plant, we may end up paying dividends for us later on. And then I would leave you with this, that I'd say consider the use of 2x2 row starter. And I was going to have question marks placed after this, because I do have to admit that we've done a lot of starter fertilizer research in the last several years, primarily 2x2, a little bit of in-furrow. With 2x2, it is true that we do not see a yield response every time. But it's also true that when we do get a yield response, it can be as high as 15 to 20 bushels. It's hard to predict when we're going to see that starter response. But of course, the whole purpose of starter is to provide those plants with that little extra concentration of nutrients at the time those young roots are beginning to develop. And if conditions are challenging at that time, the idea being is that you give some of those roots that concentrated band of starter fertilizer. It'll help it through those rough days during the stand establishment period. So a lot of people have gone away from 2x2 on the planters, but I just offer this as a consideration. So I think with that, that's all I had. I'll stop sharing.
Thank you, Bob, and thank you, Aaron. Both of you gave very informative presentations today, and we really appreciate the time you took to share with us. To close off, I'd like to spend a little time and remind you of our upcoming events. Today was the first in a series of 4, so we have 3 events remaining in January. So if you aren't registered, take some time and register for the other 3 so that you can participate live. We do have extension programming coming up throughout the winter. This slide here shows the meetings that are coming up in the next 10 days. So join us for these and keep an eye on our programming website that you can click on there below to join us for meetings throughout the winter. And our final announcement is that the 2020 eFields report is available now. This annual report summarizes the results from over 200 on-farm research trials conducted in Ohio this past year. So you can scan the QR code there to view and download that report, and hopefully you find some valuable information in there.
Sentinel, the industry-leading liquid row monitor from Surefire Ag, eliminates costly mistakes that could subtract revenue from your bottom line. Sentinel utilizes your existing in-cab display to provide instant notification of flow variances and row blockages. Sentinel is the smart choice that pays for itself. Quick Draw drives sprayer productivity. Surefire Ag's automated spray tender system can meter, mix, and load a 1,000-gallon batch in just 8 minutes. Less time loading means more acres sprayed. Quick Draw from Surefire Ag, driving sprayer productivity. Learn more at surefireag.com.